So I'm going to be talking about measurement theory. To start, I'm going to begin with defining what a measurand is. A measurand is essentially the quantity whose value we want to evaluate. So for instance, if we are trying to measure the diameter of this cylinder, the measurement will be that result of measuring the measurand, which is the diameter. So here we have a formula for the true value measurement. Y is going to be the measurement result, mu is that true value, and epsilon is the measurement error associated with the measurement. Once we start taking repeated measurements, we're going to get different values for every measurement, essentially. And the reason for that is that once we start taking repeated measurements, we're going to have a certain level of uncertainty. So one reason for that uncertainty is variation within the measurand. So in the real world, we don't really have perfect circles. So depending on where you're taking the diameter from, you're going to get a different value. We also have variation in the measurement instrument or the measurement process. So if I'm holding that cylinder down and trying to take the diameter of it, I could apply pressure to forming it and changing that diameter every time I take it. So in order to avoid having a multiplicity of results, we can change that formula. So here we have y is equal to mu, and I put m because here mu is going to be the mean of the population. And by the population, I mean the totality of every single possibility of that diameter. So we're going to have y equals mu m plus x, and x here is all uncertainty of that measurement result. So let's break down that uncertainty of the measurement result. So let's break down x into this formula where we have the formula when there's a variation in that measurand. So that first example I gave where we don't have a perfect circle. In order to have this formula, we need to assume that there's a deviation from the mean. And then remember, it's the mean of the population. And that population is all the possible values of the diameter, measurements of the diameter. And then two, the measurement instrument is free of error. So we need to only have that one variable where it's the variation in the measurand. So here we're assuming that the measurement instrument is completely accurate. So we have y is equal to mu m plus xo. And here xo is the variation of the measurand in the population. So what does that mean? It's the deviation from the mean of the population. And the population, again, is every single possibility of the measurement of the diameter. Now, let's take this formula and add the pure measurement error. So here we're still going to have mu m plus xo, which we've defined. Now we're going to introduce epsilon, which is the error associated with the measurement instrument or the process error. So this is going to be the formula, the complete formula, where we're taking into consideration all uncertainty of the measurement result. So let's talk about the different types of error. So we have absolutely constant error, which is essentially systematic errors, which means they're the same in repeated measurements, but the same in repeated measurements and performed in the same condition. For instance, if you have a caliper that's miscalibrated, it's going to be showing larger widths than they actually are. And then we also have random error. Random error is when we have repeated measurements carried out on the same object, same condition, same instrument, under the same stable conditions, but there's still an error there which could occur randomly and unpredictably. For example, we could have operator errors or environmental errors. And then the last one is conditionally constant error, which is partially random, partially systematic. Those remain fixed for the same, fixed for the instrument, but vary from instrument to instrument. And then I just want to quickly go over precision versus accuracy. So here, let's say that lowercase delta is the mean of x and lowercase sigma is the standard deviation from the mean. To have a precise instrument, we're going to have measurements with a small standard deviation. So there's not going to deviate from the mean a lot. And then for an accuracy, we're going to have measurements with a small mean, meaning, x again we define that as all uncertainty of the measurement result. So to have a low uncertainty, we're going to have a low mean, which means we'll have a more accurate result or an accurate instrument.